Hello friends, in this problem, this is an upright cylinder of radius r placed on a rigidly placed on a horizontal plane, and this is a disc tied to the base of the cylinder by a string of length L0. Initially, this disc is given a velocity V0 perpendicular to the thread. As a result, this disc will curling this cylinder strike the cylinder at the base after some moment. We are going to find out this time t. We have drawn this figure here. This is the top view of the cylinder. Let after few moments the contact point of this length to the cylinder come to this point. As the disc circulating, curling the cylinder, the contact point of the string going in this direction, and we are considering this moment when this contact point comes to this point. Let at this moment the angle made by the radius vector to this contact point from this center of the cylinder is theta. Now, as this string rolls over this cylinder, this rolled length would be r theta. So the length of this portion of the string would be L0 minus r theta. After a few moments, this disc comes to this position, making a very small angle d theta. So in this moment, in this interval, during this interval, the distance covered by this disc is elementary distance covered by this ds must be equal to L0 minus r theta d theta. So this would be the working equation of this problem. To get the total distance covered by this disc before striking the cylinder, we have to integrate this expression. Very simple this integration is. We get after integration L0 theta minus r theta square by 2. Now what would be the limit of theta? Theta must be from 0 to L0 by r. L0 is the total distance, total length of the string when the string rolls over the cylinder. We have the peripheral distance equal to L0. So the corresponding angle, that is the revolving total angle of the disc, would be L0 by r. So ultimately we get the total distance covered by this is equal to L0 r square by 2r. Now this disc will move with constant velocity. Why this disc will move with constant, not constant velocity, constant speed, better to say, that is the magnitude of the velocity remains constant. Why? Because the force on this disc here, it is the tension, and there is no displacement of this disc along this direction. So, and the direction of V0 is always perpendicular to this string. So this tension will have no work done. So we have no work done associated with this tension. So the energy of the disc will conserved and kinetic energy of the disc will conserved, and the velocity V0 will remain intact. So the total time taken would be S by V0 is equal to L0 square by 2r V0.